Hello, everyone, and welcome back. Today, we are going to be doing our very first day of our grade 12 functions. We're going to kick it off with some review of some core concepts that are going to be really necessary for this course. So, starting with relations versus functions and reminding ourselves what is the difference, because that's a very key part of functions and also now advanced functions too. So, that's what we're going to get started with today. Okay. So, as it says here, a relation is a set of data points that can be plotted on a graph. So, anything that can be plotted on a graph is a relation. Okay? A relation is also a function if for every x coordinate, there's only one y coordinate. Or if it's on a graph, no 2 points can be connected by a vertical line, right? So if we have a graph, to know if the graph is a function, we'll just drag our vertical line across and see are there any points where that line touches the graph at two or more different points. And if there are, we fail the vertical line test. And if not, if there's only 1 point for every vertical line we could possibly choose, then it would be a function. Okay, so that's basically the key definition there. So all functions are also relations, but not every relation is a function. Okay, a function must have that core characteristic that for every x value, there is only one possible y value. Okay. Also, a reminder of domain and range. So, the domain means what? The domain means these are all the intervals or values that are possible x coordinates, and the range is the intervals or values for all possible y coordinates. So, sometimes the domain and range are just all the real numbers, sometimes it's just everything. Other times, domain and range might not be. So, for example, um, let's say we have a sinusoidal function, right? In that case, the domain is everything, but the range isn't, right? The range only goes from -1 to 1. We can't go past those points for our parent sinusoidal function, right? So things like that just to keep in mind with domain and range. Another example is let's say we have some value where x is undefined. So, for example, if we have a polynomial and then over x, well, x can't be 0, right? That would mean the function was undefined, right? Or maybe we have a square root as part of our function, and we can't let that square root, or the number in the square root, get below 0. And so, any x value that would allow for that to happen, for the square root to be negative, that's not a possible x value for that example, right? So just kind of thinking about what possibilities are there. And if the true answer, which it is oftentimes, if the true answer to that is any of these, any number could go in there and things would be just fine, then you're good. Then you're good. Okay. So let's go and take a look at this example. Here it says, determine if the relation is a function and find the domain and range. So the relation is a function if for every x, there is only one y. And let's see if that's true. Okay, so for this x value, this 0, there's 10. For this 100, it's 12, and then 200, 15, 50, 11, and 150, 13. Well, I don't see any repeats. I don't see any x value that has two separate y values. It seems like every x value just has one y value. So therefore, this is a function. Yes, absolutely. Okay. Then they ask for the domain and range. So domain is just all the possible x values, or in this case, they used m, right? So all of these values are in here. And then all of these values are in the range because these are all the possible temperatures for the different altitudes that were listed. So very good. Let's move on to the second one. This has to do with hair length versus height. So the question we got to ask ourselves is it possible to have, for two people with the same hair length, to have different heights, right? Is it possible that for one x value of hair length, we get two different heights? And that is possible. Let's see if it actually occurs on this graph, though. Well, it looks like it does. Looks like it does because there's one person who has a hair length of 15 centimeters and is 180 centimeters tall. And then another person who has the same hair length, 15 centimeters, and is only 176 centimeters tall. And so, therefore, this is not a function. This is not a function. This is just a regular relation because it is possible for two people to have the same hair length, but different heights, right? So for that x value of hair length, we have height, right? Whereas with the last example, with altitude and temperature, it's not really possible that the same altitude would have two different temperatures, right? If we're standing in the same spot, there's not going to be two different temperatures. So that wouldn't really make sense for that one. For this one, it absolutely would, because it's certainly plausible that two people could have the same hair length but have different heights, because hair length and height don't really have much to do with one another. Good. So anyway, then we have our domain, which is all the possible x values here, all the possible hair lengths that we are given. And then here we have our range, which is all the possible heights we are given in this example. Okay, so that one was not a function. Let's move on to example 3. Example 3 says x is month of the year and y is the average temperature. So, first of all, is it a function? Well, I would imagine, we'll look at the numbers in a sec, but I would imagine yes, right off the bat, because um, if we're taking the month of the year, one month of the year can't have two average temperatures for that same year, right? Every month of the year has just one average temperature. And then if there's new temperatures added for like the next year, those just get put into the average, and then the average changes, but there's still only one average. There's not going to be two separate averages, right? Average, there's only one value ever for each data set. It's not like mode, right, where there could be two modes or something. No, there's only one average for each data set. So for that reason, I would right off the bat say, well, no, it's not possible, so therefore it is a function, because it's not possible to have the same month of year and have two separate averages for that month of the year. And let's see. Looks like for the first month, January, the average was minus 18. For the second month, the average was also minus 18. For the third month, so March, the average temperature was 5. For the fourth month, which is April, the average temperature was 10. For the fifth month, which is May, the average temperature is 16. And for the sixth month, June, the average temperature was 22. So this is indeed a function because there is no x value for which there's two y values. Now I will point out that there are two y values that are the same, right? January and February both have an average temperature of minus 18, but that's not the question that we need to ask ourselves in order to find out if it's a relation or function. We need to know, is it possible for the same month of year, for the same x value, are there two separate y values? Not, are there two separate x values for the same y value? And so even though this would pass, this would not pass a hypothetical horizontal line test, this still does pass the vertical line test, because we're allowed to repeat y values. We just can't repeat x values and have different y values. So therefore, yes, this is a function, because for every x value, there's only one y value. And then same thing here. They just wrote out the domain and range. They said domain was 1, 2, 3, 4, 5, or 6. And the range was negative 18, 5, 10, 16, and 22. I know negative 18 appeared more than once, but we still just have to write it once in the range. We don't have to write it twice. Awesome. The next one is relation bubbles. So eye color versus batting average. So is this a function or a relation? Well, let's think about it. Is it possible for two people to have the same eye color but to have different batting averages? Well, yes, that is possible, right? And so right off the bat, I would assume it's probably not a function, it's probably just a relation. But let's also look at the actual data here. Looks like there's a blue-eyed person who has a batting average of 318. There's two green-eyed people with batting averages of 280 and 320 respectively. So therefore, right there, we know it's not a function, because there's two people with the same x value, which is green eyes, who have different y values, right? Two different batting averages, which makes sense, right? Do we really think every person with the same color of eyes is going to have the same batting average? Not a chance. Not a chance. And then the person with brown eyes has 300, and the person with hazel eyes also has 300. Now that's okay. That's okay. That doesn't make it not a function. The thing that does make this not a function is the fact that there's two different green eyed people who have different batting averages, because not every green eyed person is going to have the same batting average. Good. Okay. Then for domain, they wrote down the different eye colors, so blue, green, brown, and hazel. And then for range, they wrote down the different batting averages. I will note they left out 340 because nothing actually went there, right? Things only went to 280, 300, 318, and 320. So those were the only possible batting averages that they gave us, even though I'm sure overall there's probably more batting averages possible, but these are the only ones that came up with this relation specifically. Okay, let's do a couple more examples and then we'll be done for the day for this review. Example 2 says, determine if each graph is a function and find the domain and range. So let's see if this one is a function. Well, let's see, if we draw a vertical line here or anywhere across, is there any vertical line I could draw where we're going to end up getting 2 points, 2 points on our graph? No, there isn't. No, there is not. Or is there any x value where there's two y values? No, there isn't. And so therefore this is a function. In terms of what's the domain, well, the domain is what x values are possible. Well, looks like I see arrows here, meaning that all these x values are possible, and then anything beyond is also possible. So I would say domain is just all real numbers, or this symbol here just means all real numbers, so that works. And then as for the range, it's asking what y values are possible. So down here, there's nothing, right? Down here in this whole space, there isn't anything. The first possible y value is 2, and then everything above we also have, right? We have those arrows again. So everything 2 and above we have. So that's why it's y is greater than or equal to 2. But there's nothing down here. This is just a bunch of empty space. And so these values down here are not possible. Good. Also, we might just recognize this as a quadratic, and whenever we have a quadratic, the domain is always going to be all real numbers, and the range is always going to be restricted depending on the minimum or maximum value, and just taking that value and saying everything above it, if it's a minimum value, is possible, or everything with that number and below is possible if it's a maximum value there. So, just in general characteristics we know about quadratics can help us with this too. All right, let's move on to number 2. This is a line, and so since it's not a vertical line, this does pass the vertical line test because there's no vertical line that I could draw here where, anywhere here, where I would end up hitting two points on my graph. Okay, so this is indeed a function. In fact, all non-vertical lines are functions, and all quadratics with the y equals ax squared plus bx plus c form are also functions as well, because they all do pass the vertical line test. And here it looks like the domain is everything that's greater than -1, because if we start on our left and we see nothing, 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 starting at -1 we have something, 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 and then it just continues on because we have the arrow. So everything from -1 forward is good, so that's why domain is greater than or equal to -1. As for range, let's start on the bottom and see where we get to. So down here we've got nothing, 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 nothing. Starting right at 0, right at that axis, we got something, 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 and so on for y. And so therefore, since 0 with respect to y was our the point where we finally got some values, we our range is going to be that y must be greater than or equal to 0. So that's my suggestion for finding domain and range with the graphs. For domain, we start at the left, we see, okay, are there points here? We go all the way to the right and we see where are there points on that x-axis with respect to our domain. And then for range, the opposite. We start at the bottom and we keep going up and see, well, where are those points? Where are those points going to be? Good. All right, number 3 is goals scored versus games played. So is this a function or a relation? Well, let's see. Is there anywhere where I could draw a vertical line and have it hit two points on our graph? Well, over here, no, we passed. Over here, we hit 2 points here, so we failed. So therefore, it's a relation and not a function because it fails that vertical line test. We have 2 points here, meaning that the number of games played is two for two different teams, looks like. And the goals scored was one for one of the teams and two for another one of the teams. So, in other words, it is possible to play the same number of games as a different team did, but score a different number of goals than that team did. It is possible. Okay. As for our domain and range, domain is just all the possible x values, right? So we have 1 is possible for the domain, as is 2, as is 4, as is 5, and as is 6. Looks like nobody played 3 games, so 3 was left out of the domain. And then for range, looks like the range could be 1, so we have 1, 2, 3, and looks like nothing for 4 and 5. So there we go. Okay. All right, let's take a look at this one. Is this a function or a relation? Well, this one would be a relation because it fails the vertical line test. I could draw a vertical line here or in many other places, and I would get 2 points on my graph. And so, therefore, it's a relation and not a function. Okay, now what's the domain and range? Let's start with the domain. Well, over here, it looks like we have nothing, 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 nothing. Oh, we got something. Got something, 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 something. Oh, until here. And now we have nothing, nothing, nothing again. So what was highlighted in pink there? Everything from -3 up to 3. So the domain is everything that's uh, it must be greater than or equal to -3, but less than or equal to 3. So we can write this, or we could even just write -3. We can also just write it like that. That will also work. We just have to show that it starts at -3 and stops at 3, and it does include those two values. Let's do the same with the range. Let's see, we've got nothing, 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 nothing. Oh, we got something. We got something, 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 until, oh, over here we start getting nothing, nothing, nothing again. Okay, so where did this stop and end with respect to the y-axis? Well, we start at -5 and we stop at +5. So therefore, it would be -5. Oh, this was y, not x, sorry. 5 like that. Or you can write it the way they did here, where they say y is less than or equal to 5 and y is greater than or equal to -5. So there we go. Awesome. All right, well, that is it for today. I hope that was a good review of domain, range, all that kind of stuff. And next time we're going to, let's see, there's some homework about domain and range. Next time we're going to learn the absolute value function, which I think for some people that might be a new function. For others, you may have learned it in grade 11. Either way, we will go in depth into it. So whether or not you learned it in grade 11, no worries. We'll have you covered. All right. Good work today, everyone, and I'll see everybody next day. Bye, everyone.